Okay, everyone's here. Please meet Dmitriy Kremer. Good afternoon, colleagues. My name is Dmitriy Kremer. I'm a DBA at Russia Today newsmaking agency. This is one of the biggest Russian newsmaking agency, one of the big three. Today I'm going to talk about monitoring of DBs. They rest on three whales: collecting of metrics, alerting, and analysis and visualization of the metrics collected. Today I would like to focus at collecting metrics and monitoring metrics as the most important component. First, few words related to physics. In the 19th century, Professor Jung held a two-slotted experiment to prove the dual nature of light, wave and crepuscular. The scientists of 20th century repeated the experiment, but they were bombarding the wall with single photons, not with a beam of light. And when they were looking at the results they obtained, without trying to fix through which slot photon passes, and they saw that photon could behave as a wave. But when they were trying to look at which slit it passes through, photon actually behaved as a particle. So even from the physical point of view, the observer can influence the system being observed. Well, what can we say about computers, virtual systems, and virtual databases? This is an object that depends a lot on the observer, because we obtain data on database using SQL queries. So it is very important what kind of SQL queries we used. In monitoring, it is very important to avoid overloading our database. And this is what I call the quantum effect, when our monitoring can influence to the negative on our system. What kind of metrics we collect? Well, those are very simple system metrics, CPU and all the other. We also are looking at the metrics of the database. It is very important to check the response time. Response time is one of the most important parameters that can allow us to judge of the performance of our system. We can have CPU loaded, disks loaded, but if our DB is still giving us good responses, it means that it works well. So the most important parameter that we have to control, first of all, and the most important parameter that we should be looking at the performance of the database is the response time. At this slide, I've listed parameters that are very important to be monitored. Most likely you monitor all of them. I'm not trying to take too much time with this matter. How can we collect the information on metrics? We need to do that in a serial mode. It means that our monitoring shouldn't load our DB with a lot of queries at one go. Our monitoring should collect the metrics it needs step by step. In this way, we can significantly reduce the load we impose on our DB.
Shall you use such systems like Zabbix or similar? I would recommend to separate the collection of metrics. Please collect metrics in scripts, and use items as storage means, but not for trigger collection of metrics. Still, we at our company use Zabbix. It's just another monitoring system. Our legacy, it's just another monitoring system, not more. This is a host-oriented monitoring system. it's not so easy to monitor services. That is a database. If you use sharding or other cloud services, distributed cloud services, it is inconvenient to use this system. But still, there are positive parts of it, like the templates. And the use of templates allows us to use metrics in your service and databases, dynamical rules for creation of metrics. If you have a new database or a table, you may use dynamic rule and create all metrics. And Zabbix has a scalable architecture with plugins and so on, so Zabbix is not the best but also not the worst solution. What are the instruments that we can use to analyze the issues, the problems that occur in the system? Here I provide the list of things relating only to the operational analysis. In the first line, it is the load analysis on server, session analysis with help of pgstat activity, and if you use Puller, like PG Bouncer, you can also take a look at its statistics, analysis of executing queries, a stat statement or stat activity, and logs. Because when we make query to stat activity in a loaded database, we see not so many queries that are executed, and at our basis there are 150,000 queries per minute. So of course we can see 5 to 6 queries in the time when the query was made. But if we see that there are many queries in stat activity, that means that we are not in the best shape, not in the best mood. But we also encounter situations when the analysis of logs is needed. Graphics and trends, graphical information shall also be analyzed to provide predictive analysis. So what happens in our bases? It happens that the majority of administrators of databases have such experience. The developers come to us and say the database fault is present, but I want to underline that the main parameter, character, is the response time. I mean, if the response time is acceptable, the database is working okay. Good. And here I want to share with you some cases for analysis of a certain load of resources, and I want to underline that the main ground for problems in databases are queries. Database works with only one way. It works with queries. It processes queries. So if something is bad, please take a closer look at queries. Queries can be written badly, but still we need to perform analysis and optimization of queries, construction of indexes, adjustment of parameters like workmem and so on. Now I want to tell you about a small subsystem that is not introduced, but it's on its way as a working stand. We can nominate it like OC meter for state structures, and we cannot allow to store our data in different clouds. And for analysis of a huge amount of logs, like hundreds gigabytes per day, when we log all queries in our databases, we started to use PG Badger and scripts. And we want to think of some new solution that would rid us of this everyday pain of analysis. The thing is, we need to preserve data in ClickHouse. It is developed by Yandex for Yandex Metrics service. So this is also one concept of Russia-based IT structures. Our aims at the projecting of the system are the possibility to store logs in this system, to lay all the information into ClickHouse, to make the regular JSON out of it, and to work with the programming. Everything that we've programmed, we need to underpin. And we are trying to use something that is a part of the community and not to make our own parsers. In the process of parsing of logs in JSON, we've passed through 3 stages. The first stage is the use of hook, but we then understood that the PG pager won't eat it. Then we tried to use rsyslog that reads primers in the format of an rsyslog out of Postgres. It was also impossible for us to make. So what did we do? We introduced a model of imfile, the cocktail, that sucks up to rsyslog and applies some parameters. This is the configuration of a syslog, the configuration of Postgres, excuse me. Here we are writing in stder. The log level is also present, and here you can see everything that is needed for logging into log file for the parsons and JSONs with the user information could be stored in the database with the time of storage. Configuration of rsyslog Kafka. This is the most important thing that we've done. This is the way to alternate the user information in the databases in the time of query and in the log with help of regular applications. In the end of presentation, you will receive an advisor, a guide for writing of regular statements for a syslog, because it was a non-trivial work. And here you see configuration of modules in file that is gluing the lines to each other, because every query is dismantled into lines. It was also our aim to calculate it. This is the JSON that we've managed to make, and the configuration of Kafka ClickHouse is very simple. In ClickHouse, there is a module for operation with Kafka. We create a table that listens to a query. The consumer is the name of entrance, and out of this table, by using means of ClickHouse, we can make analytics, make math view, create graphics, and analyze it. And in the end of my presentation, I would like to say that we don't need to forget about the fact that monitoring can load database, especially if you use such extensions like PGBar, and if you adjust Zabbix and create separate item for every PGBuffer parameter, you have all chances to lay down your bases only by means of your monitoring. And please do not forget about the time of response from database, because it's very significant. Select one is made in 1 or 2 milliseconds. But when you take a look at the graphics, you can see that the time of this query is longer. This is the sign that the database felt not great during this time, during this query. Although you can see that all the system parameters, CPU, system, and processor load, disks, everything was okay. And the main way for optimization of database work is the optimization of queries. You can adjust your system at the top way. You can adjust the parameters of the core of your system. You can calculate the shared buffer. But then you can meet a developer that will kill minus 20 that will kill your productivity by minus 20%. So in the first line, you need to analyze the queries. And we do hope that this instrument will help us, because the standard system monitoring system is not collecting this data because it's not its property to collect such data. Here can you see the useful information, the article, the paper that I've used about logs with rsyslog. And I like to assert my admiration by this program because it's very modern module system of log collection with many plugins and the possibility to create your own parser. And I think you should take a closer look at it. And I would recommend this book, Art of Monitoring, describing the general concepts of monitoring of modern systems and how to construct them, how to analyze them, and what kind of systems can we use. Thank you very much for your attention. Now you may ask your questions. Thank you very much. It was very interesting to take a look at this. My question is combined with ping select one query. We're making the same thing. We're making ping of the basis. The first question is, how often do you ask your system? We make 10 times per second. And the second question is, we're also working with Zabbix. But for us not to load basis, we needed to create a collector that is making the same thing. Actually, this was the same thing for us. We're making ping once per 1 second, and we have one collector. Thank you very much for the information. In my organization, I make this through the module and collect metrics by metric bit and packet bit. Have you thought about this realization? We tried to take a closer look at the modern monitoring systems, but we have a corporate standard, and there is not everyone chance to alter it. We are working in an inert system, and of course the main problem here is in the collection of metrics is that metrics is collected in one unit of time. So you're fixing one moment stage of the system. For the analysis of the database and queries, this is not enough. You should take a look at the whole picture at once. And to have this look, you need to see all the queries and to analyze them. And therefore, that's why we made this subsystem with Kafka clickhouse to take the queries out of our logs. And of course, we're thinking about the use of hook of stat statements, but these are only plans that are not realized until now. And still we do want to have a full picture and not the picture of 1 second or 1 moment, because when we're speaking about productivity, we see only a little share of queries that are executed right now, and it's not easy to evaluate what's happening right now, because there are some situations when not only one query makes it difficult for system to work, but there are many queries from many subsystems, and this affects productivity. When you make monitoring of huge queries, you are seeing only huge queries, but not the little ones. So PG Badger is showing this information, but to create a log to create a report on this log, we have one separate subserver that hour per hour is perennially working with the log to so that means that we have some tools for it, but 24-hour report is not enough to provide the analysis of whole problem. We need a report for a shorter period, and in different cases, the length of this period can vary. That means we're wasting many resources. I think it's the proper way for us to use a lab system to analyze the data. So you store Postgre logs for post-factum incidents analysis. But what are the markers that you apply? What are the running markers that you apply on dashboard to understand that now in our Postgre we have some problems? Because logs are okay, are great, we can understand why something happened, but what are the markers that are fixed on your dashboard and show that you have current problems with your Postgre? Okay, for now, we use Zabbix as dashboard. So the analysis of queries has no dashboard representation. Of course, we have some ideas of how we will analyze our queries, but now they are not tested and we cannot speak about this. But how do you store our rsyslog file to receive it in the in file as a text? Do you store it on the local server? Yes. It's written on the local server, and then by rotate, it's sent to the rsyslog server. So the stand, I collected the stand to make everything on one machine. But in my plans, I also plan that when rotate happens, it will be sent to the server where our syslog is working, and then it will be processed. But what about storage? The storage is the same? The disks are the same that are placed near your base. So it is performed on the same storage, but the load should be very high. But we use BNC, so it allows us to make this. Please introduce yourself before you ask a question. Andrei Zubkov. You told that the main parameter.
You said that the main parameter of response time monitoring. By response time, you mean select one or abstract response time? Because select one is something specific and, well, right. At the moment, it is select one. But in fact, I also can take a broader view on this matter. And by response time, well, during monitoring, this is select one, but response time, in order to analyze the performance of queries, of course, then will mean the response time in terms of the specific query we are analyzing. If we have thresholds that were collected in order to understand and analyze the queries, well, then we can assess how adequately a query is processed and whether it is within the threshold parameters or not. Well, another important thing, analyzing performance, we need to be looking at the time frame when we are collecting the data, as we need to understand what actions are performed by the user at this moment in order to compare what the application does and what is happening on the database. The more specific these timeframes are, the better we analyze the performance. Thank you. More questions? I would like to ask the log of Postgres. The majority of DB thinks that the disk subsystem will not be able to take all the writings because it will eventually end up with a drop down of the performance of Postgres itself. When you start writing it to syslog or devlog or DB, you will have to select between two paradigms. First, if the one receiving the log cannot take the load and you drop it, or Postgres is blocked or not blocked. Could you please explain for the audience? Well, here in fact, reading of logs from files can be performed not only at the local server. We can actually install syslog at the server, send the selected logs to the server, and then we can read files there. At the moment, we use the paradigm of dropping logs, and well, in general, we can organize buffering in order to minimize this loss. In syslog, there is a concept of queuing, which actually enables us to make quite a good buffer with a reserve to be able to support the log of the network. But if the network is down for a long time, then we will select for dropping these packages, and we make Postgres work in this way. Well, okay, let's take the last question. Good afternoon. Well, it looks like you collect logs and Postgres statements that aggregate queries, right? Right. Well, I do not understand why you are collecting that if you have pgstat statements. Well, the matter is that pgstat statements, as you rightly said, has the aggregated information on queries. It does not contain the full text of queries. It cuts the text. This is the first downside. Another downside is that you do not see the consequence of your queries. When you get the information from the log, the initial data you have and the initial data you collect, you have the time of performing or processing a query, and you can see that at this moment, at this time, during 2 milliseconds, this package of queries was processed. There were these problems and they were related to these users, so this information you will not obtain it from statements. Okay, I think here we will draw a line under this presentation. Let us give a round of applause to Dmitry. Of course, all the other questions can be asked outside this hall.